Cu mare plăcere. Era curiozitatea mea personală.
Bun.
Și vă încurajez să vă exprimați curiozitatea personală. Aici, pe insulă, este loc tot timpul de ea.
Asta vreau să văd. Mulțumesc, Daniela. Dăm în direct. Hey, Ravi.
Hey, everyone. How are you all doing?
Okay. You see me here?
Yeah, I do see you there.
Somewhere in the shadow.
And I hope you see Erisa as well.
Okay, thank you again for taking time to join us. We celebrate the 32nd anniversary of Atlantykron. So we are here for more than 30 years. Unfortunately, last year, as you know, we were online because of pandemic. But we come back. We're back in the future. This is our logo this year. We're back in the future. And we consider that we are legendary. So thank you accepting. Thank you, Erisa. We see you. And I'm happy to see that also have a media partner, which was very interesting to have you, online for the public, for the, the rest of the people which are not on the island. So what news we have? What news you have for us from Mars?
Yeah, so we were going to talk through the latest and greatest on Mars. We have a presentation. Do you want us to share the presentation, or do you want to share it on your side?
I want to ask you just for a minute, you and Erisa. We have a lot of teenagers. They are first time here. Of course, we promote the information about you, about Erisa, about NASA, but I think it would be wonderful if you just say a few words. I know you are, you do so many great things, but it's better to tell a few words about yourself and your work.
Sure, our pleasure. And so, actually in our slides, we have a slide about ourselves. And so maybe that's the best place to do that. Is that okay?
Yep. Mihai is here and he managed the connection with you.
Great. Okay.
Yeah, I'll just make sure you guys can hear me okay. But yeah, thank you for having us both back this year. We're very excited.
Yeah, Mihai, I think Mihai has a problem probably that he cannot download it yet, the presentation.
Okay.
Can you send it again and then we continue to talk?
Yeah, I'll just let me share my screen.
Okay, good. Mihai, Ravi, share screen.
Okay, do you see it?
Yes.
Okay, so yeah, like Erisa said, thank you for having us back. This is, I know, my favorite talk that I do every year, and I know Erisa really enjoys it as well. We have some exciting things to talk about. Erisa is going to talk about the work she did on the Perseverance mission, along with Ingenuity. I'll talk about the work I recently did and am doing on the Psyche mission, which is going to an asteroid. And we will leave plenty of time for questions. So get your questions ready.
Yes, we have them.
Good. Okay, so a little bit about me. I am a systems engineer at NASA, which means I'm a jack of all trades, master of none. And so I like to think of it as, if the spacecraft is an entire puzzle, a lot of engineers focus on one piece of the puzzle, but a systems engineer's job is to make sure the entire puzzle fits together. And so if someone changes their piece of the puzzle, that has a ripple effect throughout the rest of the spacecraft. And our job is to make sure we account for that and make everything work. I'll just go through these fun little pictures. So this is me when I was working on the Mars Science Laboratory mission, landing the Curiosity rover. So this was a much younger version of me. After we landed on Mars, I left JPL for a few years to work in developing countries around the world, using my engineering background to design tools to help lift people out of poverty. And so that was extremely gratifying and extremely fun. I did come back to JPL, which is where I am now. And my first job back was working on InSight, where I led some of the operations on the surface. And so this is me next to a test model of the InSight lander on Mars. And then this is just a picture of my family and me on the day we landed the InSight lander on Mars. They came to drop me off and wish us luck. And so this was a few years ago. My girls are a little bit bigger now. But that's me. And now Erisa's gonna share about herself.
Hi, so my name is Erisa Stilley. I have been working at JPL since 2006, and it was the first full-time job that I took after I got done with college. So on the right, you can see a picture of the United States. That state in the middle is where I grew up. It's called Missouri, and we joke that it's in the middle, it's a little bit off. And then I went to school in Miami, Florida, for my bachelor's in mechanical engineering, and then up to the Boston, Massachusetts area for a master's at MIT, the Massachusetts Institute of Technology. That's actually where I learned about JPL, the Jet Propulsion Lab, as a place within the NASA family, and got to do an internship and then started working full time, like I said earlier. The pictures you see are just reminiscent of some of the work that I've gotten to do at JPL. Ravi and I first worked together early in my, alongside each other on some earlier human space exploration work that was happening with the original crewed mission and next generation lunar lander for a mission back to the moon. And then we both worked different parts of the Mars Science Laboratory mission, where Ravi, like you said, was on the EDL team, and I was working on the cruise team, the team that works to get the spacecraft safely from Earth to Mars. So this is a picture of me in what they call a bunny suit, so I could go into the clean room where the real hardware was, and we were doing a test where we were making sure that when we sent commands to the spacecraft to fire the thrusters, that the correct thruster or engine would fire based on that command. So that was some of the testing we did before we launched the Curiosity rover. Flew it to Mars. This is a shot from that landing back in 2012. And then a beautiful picture, one of my favorites, from the Curiosity mission. And then since then, for the Perseverance rover mission, I was actually part of the entry, descent, and landing team, like Ravi was for the previous mission, where I got to help focus on the simulation aspects that we use to ensure that this system that we've built to go to Mars, that we can't test correctly at Earth, to convince ourselves it's going to work. And so you combine analyses and tests you can do here on Earth and models of both the environment at Mars, models of the sensors you're using of the spacecraft, and tie all those things together to try and tell a story that we think we've done the right amount of testing to try and land safely. And so we had another successful landing in February, which is very exciting. I felt more responsible for that second landing based on my job. And so I had a lot more stress that day and challenges recovering from that. But it was a great experience. And I've been very fortunate, like Ravi, to just get to work on things at JPL that people around the world hear about and know and get to experience with us when we do these landings. I also had the chance, the other thing I worked on that is really interesting to me is after the Curiosity landing, I was able to help join the testing team for the driving capability for the rover. And that taught me how the rover worked, which wasn't something I was familiar with. And then with that, I was able to start working with the surface operations team on Mars and be part of that team that would help develop the commands we use to drive the rover, to touch things on the surface with the instruments, and be a part of that interaction with the scientists and the engineering team to operate it. So that's kind of my arc at JPL. I love getting to work with people like Ravi. Honestly, there are days that feel like any other job where it's not as fun, but overall, it's been really exciting to be here. And we've picked some stressful jobs at times, but the rewards are great as well. So it's been good.
Yes. Okay. Thank you. Nice shirt, by the way, Erisa.
Thank you. I wore this just for you guys today.
Thank you for doing that. Ravi, I don't say anything about your t-shirt, but anyway, my question is about your background there. Nothing green behind you, only yellow. That is the picture from.
Are you talking about Ravi or mine?
No. It's been behind Ravi. It's a picture.
Yeah, this is actually from Curiosity. This is a picture that the Curiosity.
Yeah, and my question was, I don't see anything green.
Anything green? Yeah, I know. One day maybe we'll
terraform Mars. Something green, right?
That's some greenery.
Yeah.
Everything green is underground, right, Ravi?
That's right. We're hiding that part.
Yeah.
Okay. Thank you for your words. Now, if you like, we can go on the presentation.
Sure.
Yeah, so this is a picture of JPL. For people that don't know what it looks like, this obviously makes it look extremely beautiful and picturesque at all times. So it looks very green and there's snow in the mountains. It doesn't look that way right now. It's hot and dry and everything is brown, but it is a beautiful picture. It's a pretty, like the history of JPL is really interesting. And it's in Pasadena, California, near the Rose Bowl. Ravi had some great facts he pulled up about this. It's apparently the same size as Disneyland, the original Disneyland here in California. And typically we have over 6,000 employees at any one time. And we're technically contractors that work on the NASA missions. So that's sort of how we relate to the NASA family. We're operated through a contract that a local university named Caltech manages for NASA. So we're technically Caltech employees, but we get to work on NASA things or other cool research things like DARPA or other programs that might have some fun robotic type applications or outer space sensing and that sort of thing. So we'll talk a little bit about the mission itself. So we'll talk first about Perseverance. If you can just tell us on your side, a show of hands, how many people watched the Perseverance landing on February 18th? It's probably early in the morning. I can't see anyone. So is anyone raising their hands? You can just tell me.
Yeah,
I see some clapping. Yay. It's really cool to be able to show something like this around the world. Like you guys got to see the same data basically at the same time that we did. Because when we go through EDL, the landing sequence, it's all autonomous. Like at that point, we're so far away from the spacecraft that we don't have time to send it commands in real time. It has to do the landing itself. And so we're really just sitting with everyone else. We may understand the data differently or better. We have to respond to that data as soon as we land so that we can then hand off this new baby spacecraft on the surface of Mars to the surface operations team. But we're really watching it with the rest of you guys. So if you go to the next slide, there's going to be a short trailer about the mission, just for those who may be less familiar. And So one of the things, thanks Ravi, one of the things that isn't obvious maybe to people that haven't learned about our Mars history, we've had about 30 spacecraft from the world go to Mars and only 9 or so have landed successfully. So while we've had a pretty good string of successful landings for the US missions, our colleagues, for example, at the European Space Agency lost the Schiaparelli lander a year and a half, 2 years ago, based on an error in an onboard sensor that essentially was allowed to see rates higher than they had expected and caused the spacecraft to incorrectly calculate its altitude above the ground and think that it was time to land before it was close enough to do it safely. So it really is a challenging endeavor. And when we go to any of these planets or any moons anywhere, there's always some unknown. Like we're always having to model something. We don't have a perfect understanding of the environment that we're in. The spacecraft may work a little bit differently in that environment. And so it really is a challenging job with a lot of people spending a lot of time and effort to try and make sure what we've built is really going to do the job well. And the goal of all of it is the science, right? We're trying to get to the surface because we've built these incredible instruments that we can then drive around on the surface or in place, take measurements like the InSight mission that has a seismometer to look for Mars quakes. And so just getting to the ground safely is really the first step, because then we have to make sure that the science instruments can do what they are expected to do for the missions to work the way that we hope. One of the neat things about Perseverance is it has more cameras on it than any previous mission. So included in that are 7 cameras that we used during landing. One of them was used for new technology that allowed us to land in the site we did, which was the most dangerous site we've ever landed in before, with rocks and sand dunes and a giant delta that looks like a cliff. And then the other 6 cameras were used to just capture imagery that we could then beam back to Earth if we landed safely and enjoy looking at. And so this next video that Ravi can run, it has some of that footage. And so 3 of the cameras that were used during landing were looking up at the parachute. And when the parachute deployed, we actually got video from 2 out of 3 of the cameras. And then toward the end, Ravi, so here you can see the parachute from 2 different views. And for those of you who don't know, there's actually a code embedded in the parachute design. So if you don't know that, you can take that piece of information and go try to decode it. And then the camera that we used during landing was called the Lander Vision System camera. And you can see it here taking images that allowed us to localize our position with a map on board, and then helped us pick the safest spot we could then fly to. And that's what allowed us to land safely in Gale Crater, where we sent the rover. We'd never been able to consider a site like Gale before now. And then the last cameras that we have a view from are cameras that were looking down at the rover during landing and up at the descent stage during landing. And it turns out that these cameras very well matched what we had modeled before landing. So here you can see that view on the top. We're looking up at the descent stage that set the rover down on the ground and it's going to fly away. And the bottom left is looking down at the rover. So this is actually us landing on Mars for the first time ever, getting to see that and being able to ask the question, did the way that we model it actually match the way that it happened? So that was very, very exciting for us to get that data after we got the telemetry that said we had landed safely, after the first image that came back from the rover, to all confirm that everything had gone as expected. So super exciting. And the mission since then has been going really, really well. Along with that, yeah, go ahead. you might know, we also sent a technology demonstration helicopter called Ingenuity, and it has also been very, very successful. They had done tests here on Earth to show as best we could that it would fly in the Martian atmosphere. But most of you probably are aware that the Martian atmosphere is less than 1% the density of Earth's. And so flying anything at Mars is very challenging. So it's super lightweight. It has to have its own capability to take pictures, to communicate with the rover, to provide its own power. It's completely untethered from the rover. And not only did it complete its first couple of checkout flights successfully, but they've now used it to actually fly over areas near the rover that we would not be able to safely drive the rover, and take images and look at things that we would never get to see up close if all we had was the rover. So it's been really exciting to see Ingenuity work. It cannot travel with us indefinitely. So at some point they will have to essentially decommission the helicopter, leave it behind, and the rover will carry on. But it's already lasted much longer and gone further than anyone had initially expected. So that's very exciting as well. And the last thing I'll say about Perseverance before we move on from it, if you want to go to the next picture, Ravi, this is an example of the images from the 9th flight that happened on July 5th. And at that point, it was the longest flight that the helicopter had taken. But it uses these images to do, I think, velocimetry to help it close the solution on how far it is flying and what the altitude is that it's at. So yeah, it's been cool to see that and get the images back as well. The last thing I'll say about the Perseverance mission, for those that may not know, is it really is the first step of Mars sample return. So this rover has a coring drill that is going to take core samples, seal them up in tubes, and set them on the surface for a combination of future spacecraft to come and retrieve those off the surface, blast them back up into Mars orbit, attach them to, or basically hand them over to an orbiter at Mars, and then that orbiter is going to bring back just those samples back to Earth. And the reason that's important for us to do is, even though we send really capable instruments to Mars, they're never as good as the labs that we have here on Earth. And so as soon as we can bring back, just like we did with the rocks from the moon, as soon as we can bring back samples from Mars, we'll be able to look at them with much more powerful instruments in terms of trying to see if we can find any signs of past life that might have existed on Mars and has been, in this case, preserved in Gale Crater, where there's an ancient river delta. We believe it was a lake a couple of times, billions of years ago. And so we're hoping that if any life ever existed on Mars, it's been preserved in these lake deposits that we can core with the Perseverance rover. So there's obviously more to it. We're kind of giving you a lot of information at once, but if you want to learn more about it, about the instruments on it, about the future Mars missions, you can go to the website that you see here, mars.nasa.gov, or just Google Curiosity rover or Perseverance rover at NASA and find that information. And with that, I believe I'm going to hand it over to Ravi so he can talk to you about a very, very different, but also super exciting mission at JPL that he's working on.
Thank you, Erisa.
I'll just add to what she was saying that I'm amazed that we are able to fly a helicopter on Mars. Like, we can look at the night sky and see this little red dot, and to think we're flying a helicopter there and that we got video of a spacecraft landing on Mars just blows me away. So like Erisa said, I'm going to talk about a mission called Psyche. Psyche is the name of this asteroid that we are going to, but it's also the name of our spacecraft. So it does get confusing at times, but what's really cool about this mission is that for the first time ever, we are exploring a world that is not made of a rock or ice, but it's made of metal. We think that this asteroid out there is made out of metal. And this picture is an artist's conception of what Psyche looks like. We actually don't really know what Psyche looks like. All we know about is what we've seen from telescopes, whether it's Earth-based telescopes or telescopes orbiting Earth, looking at Psyche. But we've never gotten a really good picture of Psyche. We just know that it's interesting and it's different than every other asteroid in our solar system. What's extra cool about Psyche is that we think Psyche might have been a planet at one point in time. And so there's lots of different theories about this asteroid Psyche. And this one is my favorite, mostly because it has a really cool cartoon associated with it. And so I want to talk through one theory about how Psyche the asteroid was formed. So you can imagine a planet here where we have the normal parts of a core, which is the hot part inside, the mantle, and then the crust. The crust is the outside part. And the theory is that one day a asteroid or planet or moon or something collided into Psyche and just obliterated it, smashed it to pieces. And because it's such a big mass, this core, for the most part, stayed close to each other. And eventually its gravitational pull pulled it to where it was staying close, but it cooled because space is really cold. So it cooled and started to harden. And these purple lines you see are indicating a magnetic field, which if it was a planet, there's a good chance it had a magnetic field. But if it has a magnetic field, it was definitely a planet at one point in time, according to the scientists. And you can imagine little volcanic eruptions and the core is dwindling and it's continuing to cool. And so now we think we're left with this asteroid that is just made out of pieces of metal and rock. And so this is the theory. We are sending a spacecraft to Psyche. So this is our Psyche spacecraft, which is, this is about the height of a basketball goal. And this is just bigger from end to end. This is just bigger than a tennis court from one end of the solar arrays to the other. And we're sending this to Psyche to figure out what is this asteroid? What is it made out of? And so we're sending a camera. We're sending what we call a spectrometer, a gamma ray and neutron spectrometer. And spectrometers tell you what elements they see. They can look at something and say, oh, I think there's some, whatever element in there. And we can dial our spectrometer to look at certain elements. And so we've picked the elements that we think are most likely to be found there, but also many elements that we think are not likely to be there, because we are always surprised when we go to a place. Anytime we've done exploration, we've always been surprised at what we find. And so we want to make sure we allow to be surprised. And we're also sending a magnetometer to understand, does Psyche have a magnetic field? If it does, 100% sure that it used to be a planet. The reason this is interesting to us is because if we want to study Earth's core, it's very hard. Earth's core is way deep down inside the Earth. And so we can't really just study it. But if Psyche did used to be the core of a planet, we can orbit it and just really study the core of a former planet. And then that can help us understand, how did planets form in general? And maybe what is the fate of Earth one day? Right now, we're in a really exciting phase of the mission where we are building our spacecraft. So we are in a clean room. This is what Erisa was talking about when she was in a bunny suit in the earlier picture. We're wearing these sort of pseudo bunny suits where we get to, we want to make sure that we don't shed our germs or particles or a piece of hair on the spacecraft, because these spacecraft are very, very, they're very sensitive to particles because it can mess up the computers. And we don't want to send contamination when we go to other places. And so this is our spacecraft. It's being built. These are booms up here where some of the science instruments will be. We'll have magnetometers on this boom. We'll have spectrometers on this boom. This is an antenna that will talk to Earth, so we can send information back and forth. And this is just a small part of the team that helps make this happen. It's going to take, we're going to launch next summer or next fall, late next summer, let's say, August 2022. It's going to take about 4 years to get to Psyche, a very long time, because it is far. But also we're using electric propulsion, which is, typically we use chemical propulsion, like when we go to Mars. We're using electric propulsion, which is similar to what Dawn used when Dawn visited an asteroid, another project that Erisa worked on. And then we're going to orbit Psyche for about 2 years and map the asteroid and learn everything that we can about it. I did mention this is a small part of the team that helps make Psyche happen. Erisa and I wanted to talk about a core group of people that help make every mission happen at JPL. we've been talking more and more about diversity at JPL and, as people in general. And so we wanted to really point out that, women have such a large contribution to the missions that happen at JPL and everywhere. And these are people that come in all different shapes, all different colors, and they are extremely essential to making missions successful. Erisa herself, she didn't mention it, she's going to be part of the next spacecraft that goes to Mars, and she's going to be in charge of something really important. She's going to be in charge of making sure that every component on the spacecraft can do its job. She's going to be called the verification and validation lead. So she makes sure that not only is the entire mission going to be successful, but all the way down to every single component. That is her job. She's in charge of a large team of people that make sure that we test our spacecraft to the full extent possible. And so it's a very big task, and one that she has earned through all of her hard work, but also just an example of how women have a lot of leadership roles at JPL. We can still do much better at JPL, but we are starting to do a little bit better. Erisa, do you want to add anything to that?
I really appreciate that, Ravi. Thank you. It also turns out that a mission that is launching sooner than the next Mars mission needed some help from some more experienced engineers. So I'm actually going to be transitioning from that role you just described to a new mission called Europa Clipper, in a lead role as well. So which launches in 2024 and goes to the Europa, which is the moon of Jupiter, a moon of Jupiter. So I need to update Ravi, obviously, on what's going on with me at work, but also, yeah, it's just, it's good. It's nice to have the opportunity to actually lead in some of these big missions, and I'm looking forward to doing it. So yeah, thanks.
Yeah, and we wanted to make sure that all of the young women at Atlantykron also see that it's not just men in these leadership positions. I know that typically that has been the case, and now it's definitely not the case. And you can definitely do anything that you set your mind to. The last slide we'll show here is, because of coronavirus, everything has been closed for a very long time. JPL is not doing tours. What's the silver lining there is that for folks like you that live very far away, and it's definitely not convenient to come to JPL to get a tour, we've beefed up our virtual tour capabilities. And so you can go to this website, jpl.nasa.gov/virtual-tour, and get a glimpse of what it's like inside JPL. And so I think JPL has done a better job of this virtual tour. I encourage all of you to check it out. But with that, I'm going to stop sharing, and let's take some questions.
Okay, thank you. Thank you very much. I will start. I have one question at the beginning, and then I let participants asking you. I have a curiosity if you have any kind of cooperation with other scientists from other space agencies around the world when you implemented your projects.
Go ahead, Erisa.
Yeah, I can say at least to start, and then let Ravi jump in. Most of the time, there are instruments on these spacecraft that are contributed either from scientists that are part of universities here in the United States, or with organizations and universities around the world. And so I'm less familiar about some of those details because I'm typically not working directly with the instruments themselves, but there are engineers that we call instrument engineers that basically are the interface between a science instrument and the spacecraft, and making sure that that when the instrument gets delivered, it's going to fit and live within the power or the data constraints that the spacecraft has, and that the spacecraft's providing the right capabilities back to the instrument. And those have come from Germany, France, Norway, all kinds of places. So that's one of the key ways. Like our science, the people that are involved in the science part of the missions is much more international typically than the engineering part for what we do at JPL. Engineering is a little bit trickier. Like for JPL specifically, it's usually like US citizens and people that are here or contractors here, or we're getting maybe parts done by other NASA centers. Like for the Europa Clipper mission, we're having the propulsion module and the telecom or communications module provided by a different center and being integrated at JPL. But from a science perspective, it's always very, very international. I think for the Curiosity mission, we had 300 to 500 scientists at any one time involved in the mission. And I'm sure that's true as well for Perseverance and for some of these others as well.
Thank you.
Yeah. The only thing I'll add there is we do have a project called NISAR, which is a joint collaboration with JPL and India. And so that is one example of, from a building the spacecraft point of view, collaborating with another country. But Erisa's right, for the most part, the science part of the mission is definitely where we do international cooperation, engineering less so.
Now that Ravi mentions NISAR, the sample return mission, the Mars return mission is also internationally based. So ESA, European Space Agency, is providing what they call the FETCH rover. So the rover that's planned to go pick up the samples and return them back to the spacecraft for launch off the surface. And I believe parts of I'm trying to remember who else is involved in that, but there's some other international components for that as well.
Okay, and this is a small one. You are not alone on Mars. It means China is there, right?
Yes, it's very exciting. China is on the surface, and is it UAE? The United Arab Emirates also have an orbiter that is successfully going around Mars and taking new science measurements. So it's very exciting.
Okay, the question is, taking into consideration, the cooperation between United States and China and the condition today in the science part, because you are there together with the Chinese and Arabs, you have any kind of sharing of information at the science area?
I'm unaware of any collaboration that we are doing with China from a science point of view. It's possible, but I think Erisa and I are not really in the loop with the science part, unfortunately.
No, okay, it's fine. I was just curious because we talk about the curiosity and perseverance, and now I switch to my colleagues here because we have some questions. Let me introduce the first one. First questions come from, introduce yourself and look to the camera here.
Good evening, my name is Raul, and my question is, what's next for the Ingenuity helicopter?
I wish I could give you an answer. I mostly at this point just kept up with whatever they've done next and not really what the next plans are. I know that the science team, Ravi, do you have any maybe more up-to-date information before I take a guess?
No, you should take your guess and then I can maybe elaborate.
Okay, I know that the science team that are focused on what the rover is looking at, they're getting ready to core their first sample. And so really what's going to happen, I think, going forward, because the helicopter has essentially done all the things that were sort of the minimum set of accomplishments, what I think will happen is the rover will sort of move along at the cadence or at the speed that the science team is interested in looking in new areas. And the helicopter will continue to go along with the rover and do and slightly expand what it's doing, maybe do longer flights, continue to look into areas that the rover can't get to, because it's still information for the science team to understand Gale Crater. If they can get the helicopter up over ridges and over sand dunes where we couldn't drive. So it's still very valuable to the science team for the helicopter to do that. But I think that where they go is really going to be driven by what the scientists are interested in from a rover perspective, and the helicopter will follow and do what it can along the way.
Okay, thank you.
Yes.
Hello. My name is Antonio, and my question is, the fact that Perseverance rover is search for traces of life on the rock Mars can be considered some sort of paleontological or astropaleontological research?
So I think your question was the fact that it's looking for life, can that be considered astrobiological research? Does that capture?
Yeah, something like that.
Yeah, so I think that is the area. It's interesting when we think about the science, there are so many different areas of science that people study, and astrobiology is certainly one of those. So yes, I think that is considered, the search for life is considered astrobiology, and then there are others that we're maybe more historically used to, like the geologists, the planetary scientists that are looking more at the history of the surface of the environments, or that sort of aspect. But yes, you nailed it. Astrobiology is absolutely what this falls under.
Hello, my name is Stefan and I'm 11 years old. My question is NASA much more interested in Moon and Mars in one place, or all the other exoplanets and asteroids and moons?
Yeah, I can take a stab at that. So I think I love the question. There is interest in all of these places, the Moon, Mars, and other planets, as well as looking at exoplanets. The reason you hear so much about the Moon and Mars is because it's a place that we want to send people. And so it takes a lot more money to send people somewhere, and we spend a lot more money just doing a robotic exploration in those places. And so, and it's a place that we can land on, right? And we can land there and drive there, unlike many of the other places that we go. And so it's different in that way. And so I think we hear about it a lot more, but we are interested in all parts of the solar system and universe.
Hi, my name is Luca. I'm a student, and I have two fast questions. The first one, is there any trace of useful resources to build buildings on Mars, like, I don't know, metals or rare metals? The first one. Do you want to say the second one?
I think we're just looking at who's going to answer the question.
I am, so on Perseverance, we have successfully shown that we can take CO2 from the Martian atmosphere and convert it into oxygen, which is considered an in situ resource utilization, where we've proven now that we can at least create oxygen. I'm less familiar with what future capabilities people have been thinking about or starting to develop based on materials that we think are available on Mars. I'm more aware maybe of heavy metal mining in other areas. I feel like the Moon and I know that's and asteroids, right? I think asteroids are often a big source of that. Ravi, I don't know if you know more.
Yeah, I think folks have talked a lot about mining on asteroids. I don't know that it's been done, but it's been talked about. Yeah, I think Erisa is exactly right. I don't know that I've heard much about doing that on the Moon. Sorry.
And the second question was related to the previous one, because I wanted to ask if you do have any estimation if or when we'll have, I don't know, a biodome to sustain life on Mars.
Right now, it seems it almost seems more. Sorry. So NASA has been talking about sending people to Mars for a while. I think that there are a lot of challenges in doing that, but we are working them. We being NASA, as well as partners like SpaceX and others. I haven't heard of a great time frame that I believe when humans will go to Mars. We often throw out dates, but it does take, there's a lot of challenges to solve. The biggest one, probably political, honestly. It's having sufficient funding over many different presidential terms to actually get the job done, which is maybe why places like SpaceX will hopefully even get there faster than us, because they don't have to worry about some of those political issues. So I don't have a good answer. Erisa, you might have a better answer.
No, not necessarily. I do think it's interesting, though, to think about the effort it takes for us to inhabit a place like Mars and start to better appreciate what we have here on Earth with our trees and our water and our wildlife. And just the thought of what it would take to replicate that somewhere else is sort of, I mean, like Ravi said, it's the stuff of science fiction still at that level. But in terms of something more simple, like I think you're asking about, like a biodome, I don't have a good timeline either. I agree that our commercial partners are probably going to help us get there to that reality sooner than we would without them.
Okay, next one.
Hello, my name is Catherine, and I have one question for you. Do you have any trace of bacteria found on Mars, or any clues that there is bacteria on Mars?
So back in the 70s, there was a claim made through the Viking missions that we thought we had detected life, and then it became inconclusive. And the biggest reason was because they realized that the cleanliness standards that we have today to keep our spacecraft clean before we send it somewhere. You heard Ravi talk about that a little bit with the bunny suits in the clean room. We didn't keep things as clean back in the 70s. And so they couldn't confirm whether or not the life that was detected had actually been brought with the spacecraft to Mars, and that that's what we found. So we're much more aware and careful with that now. But aside from that one conclusion that was inconclusive, we have not confirmed, at least not in a credible way where the science community at large has agreed that they've been able to kind of replicate that result. We have not, as far as I know, found anything that gives us that we would consider to be an actual finding.
Okay, thank you.
Mm-hmm.
Okay, we have one more. How many minutes we have?
I think 5 more.
Okay.
Hi guys, I'm Noro, 42 years old. And my question is, I saw that you are interested in a metallic asteroid right now to inspect and so on. I suppose at some point you are interested in exploiting that metallic asteroid. And my question is, what do you think is the best procedures in order to actually do that? Because it's quite different from the normal metal exploitation on Earth. Thanks.
Yeah, so from NASA's point of view, we are more interested in learning about this asteroid because we think it used to be a planet. We think there's a lot of scientific value in this asteroid. Now, there are many private companies that are more interested in the monetary benefit of drilling, mining the asteroid, and bringing that metal back to Earth. And but on the NASA side, we're really focused on the scientific exploration of the asteroid.
There have been other missions where we have included an impactor, right, to create an ejecta so that we could still study what we think that was under the surface. So the Hayabusa, I believe Hayabusa might have had something like that for its study, which is a Japanese mission. And then a recent, which is a sample return mission from that source. And then the OSIRIS-REx mission, which is a NASA mission, also was a sample return mission where it actually made contact with its target and got some sample and came off. And so there's images from that as well. So there have been cases where we've sent impactors to then look at the ejecta. I think Deep Impact is another one that was a JPL mission as well. But for Psyche specifically, there isn't a plan to do that, as Ravi said, at least not for this mission.
Okay, so thank you. I think this was the whole question for the public. Before we close our conference this evening, I also just question regarding the cooperation with Mr. Musk or Mr. Bezos, because also they look very interesting going out in the space, and of course they are optimists. How they, if they cooperate with you, it's been in the programs, because I know they do the cooperation. They have a cooperation with NASA as agency, but with something with Europe programs or nearby?
Let me make sure I understand your question. Are you talking about cooperation within NASA with our commercial partners, like SpaceX and Blue Origin?
Yeah.
So I can tell you what I know about that's happening now, and then let me know if you have if you have a follow-on, or maybe Ravi can chime in as well. So there's a very specific thing that's exciting for the Europa Clipper mission that I had mentioned, and actually I believe this is true for Psyche as well. Both of those missions are going to be launched on a SpaceX provided launch vehicle. So that's one service, so to speak, that SpaceX as a company has now contracted with NASA on. Both NASA and Boeing are also, both SpaceX and Boeing are also developing our next generation crewed vehicles. So we've already successfully flown a crewed and cargo missions on SpaceX, built hardware to the International Space Station. I know Boeing is still working to develop their capability as well. And in terms of things with Blue Origin, I think their big thrust in development was related to this return to the moon that we've been talking about. And there was a contract recently awarded, I think, exclusively to SpaceX, which has upset some companies like Blue Origin because they saw it as unfair and sort of an early, like it was too soon of a decision to make given where they are in development. But those commercial partners have been extremely important in helping NASA essentially get more efficient and more productive in terms of creating some of these capabilities, again, that we had back in the 60s, and then, just didn't have the same funding and desire to do in the interim. The desire is there, but the funding's been a real challenge, right? Yeah. And so I think the other thing I think is really important is the fact that it's not just one company, right? There's a couple of companies that can really provide that competition, which is going to make them more innovative and in the end, hopefully be better for all of us. So there's definitely a lot of collaboration happening and working together. But for better or worse, those companies are also independent, right? They get to decide at some level what they want to do and how they want to do it. Yeah. So that's what those interactions look like from my perspective.
Yeah, I understand. Thank you for the answer. I see a nice picture from GPL with a lot of people. Ravi told us that they bring their contribution for the mission, right, from NASA. And I see there are a lot of women, right, Ravi and Erisa? Okay, my question, when we will have the first woman on the moon? Astronaut.
Yeah,
as I know.
Yeah, it's a good question. I forget the timeline for going back to the moon, but it definitely, I'm pretty sure the plan is that the first trip will have the first woman astronaut, and that should be within the next, within this decade.
Okay, it's good. Decade is nothing, just a few years.
Yeah.
Okay. Thank you very much. Again, I'm also optimistic, and I hope we will have one day a chance to be together here, because we would like to have you here in physically. You are our friends, and every year you share with us a lot of information, and because of you, we are, let's say, more happy because we know more than maybe others know about what are you doing there and what's happening in the space with your beautiful toys, which are working now in Mars. Thank you again, and I ask my friends to just give you all the applause.
Thank you so much, and thanks for having us.
Lisa and Ravi, thank you again.
Yeah, enjoy the rest of your week. We hope that it's productive and fun for everyone.
Yes, thank you. Have a nice day over there. And take care about the Mars. Okay, bye-bye.